is what I have implemented and will release at some point in the near future. But there are certainly many things that I've not yet implemented that would make it much smarter and much more applicable. And I think there's a lot more than what I have even on this slide to make it better. But the best thing you can do is improve your fitness criteria, both in terms of integrating things like code coverage and log analysis. Of course, would help make things smarter. But also, I mentioned advanced flaw-specific testing to make sure that to improve the degree of confidence we have that when a flaw-specific fitness criteria fires back and says, you know what, I found a SQL injection, I'm pretty sure. The better we can make that, the better the evolution will be. We can also do improved breeding. What this approach that I presented here looks at is primarily parameter and request based. I did not mention much about taking into account state as an input to your test systems. But of course, the more that you do, the more that we take that as an input, we can do things like have going through 3 different requests and having state be propagated across them, and having that be something else that we take as a fitness criteria would make it much smarter and better. And then also stateful tests. Just mention that. I should look at my thing more. So special thanks for offering their time and feedback from Brad Hill of ISAC Partners, Andreas the same, and Tim Newsham of the same. They have helped me with a lot of bouncing ideas and helped the tool very much. And then also, if you look at the white paper that accompanies this talk, I did mention a large number of cited academic and security practitioners that have been working in this area, whether it's pure evolutionary algorithms or people like my previous presenter who spoke on gray box fuzzing, or last year's Sidewinder people. There's a lot of great ideas out there, and it helps to be building on that. So questions and answers. I've gone a little bit short. I anticipated more of the questions, but we have a good half hour if anybody would like to talk further. Thank you. Oh, yes.
I do have a question. Isn't the main criteria of the quality of the tests the question what kind of feedback you actually get back?
Mm-hmm.
Because I think, just to follow up on your example with the SQL injection, if you actually have a SQL injection, but the exception that's being thrown is being caught, and you're just being redirected to the login page, for example, this is something that you're not going to notice as feedback on the application. Mm-hmm. So you might as well schedule that type of test back, when in fact the code flaw is still there.
Mm-hmm. So the question was if somebody, to paraphrase, if somebody, this approach could be fooled if one were to have smarter exception handling to make it so that one would not necessarily see the exception trace or the dirty words that one often sees with that. Is that fair? The one thing I would say there is that that's actually why I would propose both the magnitude of change as well as the flaw-specific change, because even if you did not see the specific ODBC word or anything, or JDBC or error, you would see that the behavior was significantly different when you put an apostrophe in or another SQL injection dirty character versus when you put in the letter Q. You would notice that. I had another question. So that would be something that would still benefit that, but of course it would be less efficient than if you absolutely knew that there was a SQL injection there.
Yep.
Any more questions?
Cool. Thanks, man.
Oh, right in front.
So, when you're talking about a testing architecture, how do you organize your test cases here, right?
Mm-hmm.
I'm not looking are you testing mainly testing towards the website?
Mm-hmm.
How about other applications, which it's hard to validate the end result?
Mm-hmm. The question was that many of the examples I cited today were based off of web applications and flaws that tend to affect web applications, and what would happen if we were testing an application other than a web application. Is that fair? Paraphrase? Okay. I would say that many of the flaws that we're looking at here, or the general approach would still apply. If the endpoint was an RPC server as opposed to a HTTP web server, then I would still be able to see magnitude of change. It might occur that a that the server simply stops responding or it responds with different data. But I would still see some big change. And of course, if I were creating the error-specific flaws and things I normally look for in RPC interfaces, then I might architect those so that they would look for specific RPC error codes or things like that. The key thing is that from an architectural perspective, you can usually come up with things that are broadly applicable on both of those. And of course, if you do have interactive access to the system, then code coverage, debugging, log analysis, all these are the things you could feed in, which would still be applicable. But the general framework of understanding your classes of tests and choosing from them would still apply.
So normally, like your test would normally use JMeter or
Mm-hmm.
or just put all the test case in a big XML file.
Mm-hmm.
That's normally what we do. And how could you help us to, for example, we can redo our test cases. So how do you interact with what we have right now?
Mm-hmm. The question was that right now the team that she works for has a large set of test cases and an XML file that they execute on. Is it just a static test suite that you run every one of them in there and then? Okay. Well, I would say that there's no harm in running those again, but the big problem with that is that you will never find a test case other than what you're specifically looking for. So if you have a 200 test case document, then you will not find what would have been found if you had 201. And what I would say is that you would want to add in specific, especially the random testing, to broaden your test coverage beyond what you're expecting. The big benefit of fuzzing, I would argue, is that it gets you out of the specific, I know this might go wrong, and so I want to test for something broader. I know that SQL injection is hex 27. What happens if I test for hex 3E or 9C or something that's a little bit less commonly tested by people? I'll get to you in one moment. But what you would want to do is incorporate some of these techniques to broaden your test coverage outside of those original test cases. And if those test cases are things that look for flaw-specific things, you might want to organize those into the flaw-specific test suites and have them be selected also. I'll get back to you if you have another question, but question over here?
If you have 200 test cases, some of them might well include random testing, and then
Mm-hmm.
it's just a matter of hit or miss whether it gets, whatever it is that will trigger something, if there's something PP there.
Mm-hmm.
And so usually, one of the things I always look at for adding new test cases or test suites is to look at what are known flaws in either the specific application, if possible, or a particular class, which the class is known.
Mm-hmm.
And if you bring up the slide, we have different classes. Any of them with their classes, different that, like that. Okay. What I would always do for this, since we're never going to completely eliminate any of them, but we're going to go and prioritize it. You also prioritize it horizontally, as you can see with the percents, and vertically, as you can see with the arrows.
Yep.
I usually go for more of a decision tree type thing, where I'll have a particular test case that will be like, if this thing returns something bad, I should bang more here.
Mm-hmm.
So that way it helps me prioritize the tests. What
Yeah.
do you think about that idea?
I think that that's actually a very similar approach to this idea, in that what the proposed thing was that you have more of a decision tree based way of selecting test cases than what was discussed here along the lines of probabilistic selection. Certainly, one of the things that was blown over rather quickly but mentioned is that using improved heuristics is something that can optimize and does optimize security test cases. I know that if I find a SQL injection with apostrophe, I don't need to start going and trying quotation mark, parentheses, comma, and all the other things. So I can certainly get rid of a lot of things there, and that's something that hopefully will naturally be present in this system as well, because that apostrophe will bubble to the top of SQL injection test cases while the others go down. The one benefit I would say about that is that even with the decision tree, you're stuck with a lot of what you know, and the evolutionary algorithm can find things that are a little bit outside of it. Again, the escaping the local optima.
Well, the decision tree is just used for prioritizing based first on the fact that in either system you completely eliminate test cases, you prioritize it.
Mm-hmm.
So since it's used to start, and if you notice any indicators to prioritize, it
Yep.
doesn't mean you stop there.
Yep.
You do continue with time permitting and
Mm-hmm.
your random buzzing or what have you.
Well, it might be that we're talking about the same thing then. Any other questions? Right up here. Mm-hmm.
have a static presentation.
Oh, yeah.
So that all the previous ones you did already, you cover every time. So that, let's say you release the product, you want to release an SP1 or SP2, you want to make sure that you don't do just evolutionary and long cases.
Mm-hmm.
Make sure that all the bugs you already fixed in the original one doesn't happen again. As two different buckets of fixes.
Oh, most certainly, like a regression test suite and then a go out and find more bugs test suite. Yeah, most certainly. I think that I would not argue against going back and trying those old ones again. Again, if it doesn't, the one issue that often people fall into is that regression test suite becomes tens of thousands of cases that some person has to execute or that some person has to automate, and it becomes something where so much effort is put into that there is not as much effort going out and finding what's the new bug, what's the new evil thing to find. And so I think they're complementary, but you must take into account the limited nature of how much time or money can be spent testing things.
Even when you're doing evolutionary testing,
Mm-hmm.
say you release the original version, you ran your tests for a long time, like some of the long ones, 7 cases.
Mm-hmm.
And when you make a huge number of changes, say you release an SP1 version back, you have to start from basics because you can't use the same optimized set.
Mm-hmm.
Because things might have changed that some other case might be of more value than before.
Mm-hmm.
So you might end up spending more time. Like having both sets is
I agree. Yeah. The person asking the question is saying that having both static test cases and something that's more flexible, like an evolutionary system, are beneficial. And I would agree. You certainly want to make sure you cover your old tracks. Sun would have felt that was very important if they had looked at a certain telnet bug not too long ago. So, question right here.
Do you think that measures of robustness are just completely impossible, or just not possible now? Do you think I'm nuts? How do you think about this?
No, that's
Measure robustness.
the question is the question is, how do I know when I'm done? Is it silly to think that one can capture robustness or security assurance? And is that fair?
yes.
Okay. I would say that the measures that I've seen that are accurate are order of magnitude measures. We don't have a specific, you're secure now. Yeah, and so, but we also know that if I work with a client, and this is the first time they've ever called in a security expert, and they don't have anybody internal, and they haven't really thought about security very much, it's a bloodbath. You start off on request 1 or code page 1 or whatever else, and you find bugs all over the place. And that some of our other clients have put a whole lot of process into trying to address security flaws. And the amount of flaws that you find there is a couple of order of magnitudes lower. And so, what do you say to either one? Do you say the first one that, you have security flaws, you're not secure? Well, even the people with orders of magnitude less still have security flaws, but they clearly have benefited from the investment that they've made. And so it comes down to a lot of what are security metrics. Actually, there's a great book on it. I'll plug one of my former coworkers, Andy Jakewith, who came out with a book called, I think it was Security Metrics specifically, where he goes into a lot of detail on trying to capture metrics and trending, and it's the most comprehensive treatment I've seen on that. But in terms of when is security testing done, this is something that's a great question because we get it a lot, especially when people hire us. We show up for a month, we do our testing, and then we leave. And a lot of people would like that to be the